Chapter 27, Object-Oriented Programming, for short OOP, and some say OOP. What are the learning objectives? By the end of this chapter, you should be able to show understanding of the terminology associated with OOP: objects, properties, methods, classes, inheritance, polymorphism, containment or aggregation, encapsulation, getters and setters, and instances. Whole lot of new words, but not to worry. Show understanding of how to solve a problem by designing appropriate classes. So classes is the main key word here in this chapter, classes. Show understanding of and write code that demonstrates the use of OOP. So basically in this chapter, we will be starting with the class, the main thing. From the class, it's like the original template. We make copies called objects. We take objects from the template called a class. Then they have properties, methods, inheritance, polymorph. These are the characteristics of object-oriented programming. Those objects or classes have qualities called inheritance, polymorphism, containment, aggregation. Getters and setters means getters are to get the information, and setters are to set the information, various attributes. Attributes means variables, and instances. Instant. When you make an object from the class, it's called an instance of that class. So for the moment, they are all new words and it's a little bit hazy. You may not understand it, but let's go through them one by one. Concept of OOP. In procedural programming, program is divided into functions. Procedural programming, that is, ones we are used to earlier, follows a top-down approach. Starting from the top, go down to the bottom. In object-oriented programming, program is divided into objects. Follows a bottom-up approach. Almost like physical objects, you might wonder what these objects are. Of course, it's software, tangible, but they appear, they behave like real objects. And it follows a bottom-up approach, not top-down, bottom-up. Example, Java, Python, C++. So the Python, the language that we are doing, is an object-oriented programming language. Related data items are grouped together into record data structures. I hope you remember record data structures. When we did the abstract data types, user-defined data types, got the record data type or record data structures. Example of using a record. The car manufacturer and seller wants to store details about cars. These details can be stored in a record structure as follows. Type, that's a keyword. This is pseudocode. In pseudocode, it's type, and the car record is the name of the type. And the normal variable, the variables are declared here using the primitive, the known data type, string. These two are string, and this is date of registration. It's a kind of date-like thing, and engine size, we are not giving anything here, just giving blank. Maybe integer, right? Integer, sorry. Yeah, this has to come. This is the integer. Date of registration like that, then, sorry, again, there's a problem here. Formatting problem. Date, that's a date, the type is date, and here the engine size is integer, where it's a number, and purchase price is currency. This is in pseudocode. To access and assign values to the fields of this record. Procedure. Update registration by ref this car to access this the new registration, right? Registration by way. So update registration is a procedure name. This is a header. You know by now what a procedure header is. Update registration by ref. You know there are two ways, by ref and by value. By reference, by value. The two variables, they behave in different ways. This car, and the type is car record. Where is the data type? This is the one. But we have defined there. We are taking this as a, instead of saying like this colon and integer here, colon and car record, and that is the type. By value, new registration. Then this car dot registration. You know the dot notation we learned? This car dot registration. So this car is this one, this object, and dot registration. This is coming from here, from this class. This is like a class, and these are our object, and this car dot registration equals new registration. So the value passed by this new registration will go into this end procedure. Can also access the record fields directly from anywhere within the scope of this car. So this car is the object. This car dot engine size equals 2500. That will update the engine size with the value 2500. And classes in OOP. So classes, that, as I told you, the main item. Object. Data structure and the subroutines grouped together. So an object is a data structure. Subroutines, there are some subroutines inside that grouped together. They are also called methods. Data of an object are called attributes. Like fields, right? Data of an object are called attributes, and the subroutines acting on the attributes are called methods. So after looking at a diagram, we can come back here, or yeah, let's have a look at this diagram. Oh, no, it's far away, so let's postpone it for the moment. So for the moment, you have to remember is there are attributes in this object, and they can be accessed only by these methods, subroutines, which are defined related or relevant to this object. Nothing else. No one else can access this. A programmer cannot directly access those unless you go through these methods. Very important feature. Attributes can only be accessed through methods. That is what it says. Direct path to the data is unavailable. All right. Attributes are referred to as private. So therefore, attributes are naturally referred to as private because they can't be just accessed. You have to go through another process. Methods to access the data are available to programmers. So the programmers have to use the methods, and they are public. They are public, they are available, the methods, but not the attribute. Attributes are available to programmer through the methods, not anywhere else. Data being combined with subroutines is known as encapsulation. So the data or the attributes and the subroutines or the methods. In short, the attributes and the methods are encapsulated. Like in a capsule, your medicine in a capsule, you get the medicine inside this. It's covered. To use an object, we first define an object type. An object type is called a class. So we create it. We create the class first. Classes are templates for objects, like a template, like an original thing. You keep it. You don't use it. You keep it and take like a photocopy. If you have an application, the original you keep and then don't use it. Or let's say take a test paper, past paper. You have the original. You don't write on it. You keep it safely as the original. Then you take, if you want to answer, you take a photocopy of that and then answer. Same way, this class is kept like that. Classes are templates for objects. So objects are made out of, made identical to the classes. When a class type has been defined, it can be used to create one or more objects of this class type. So once the original is done, then you just make like taking photocopies, create objects. Very simple way. Object is an instance of a class. Instance, like a copy, right, of the class. So let's go through the key terms. Object, an instance of a class. When you take a copy of the class to an object, it's called an instance of the class. Attributes, the data items of a class, also sometimes referred to as fields. You know the fields in a record, right? Methods, the subroutines of a class. Subroutines are small programs, procedures and all that, like acting on these data items. Encapsulation, combining data and subroutines into a class and restricting external access to the data. Encapsulation, like protection. Class, a type that combines a data structure with the methods that operate on the data structure. What are the advantages of OOP? And when you compare with procedural languages, advantages of OOP over procedural languages. The advantage of object-oriented programming is that it produces robust. What is robust? Strong, durable, hard, right? Robust or solid, right? More reliable code. So you can rely on the code. That is one advantage of object-oriented programming. The attributes can only be manipulated using methods provided by the class definition. So, what is the advantage? Protected from accidental changes. There is no chance of accidental changes, errors, mistakes taking place. Classes provided in module libraries are thoroughly tested. So classes provided in module libraries, that is, there are module libraries. If you take the language Python or any other language, with that there are certain classes, standard classes, which are provided. Of course, we can create our own classes according to our requirements. So what is provided in the library, they call the library, are thoroughly tested. The meaning is like beta testing and various kinds of testing all over the world. If there's an error, the one user will report it, and then it will be corrected and redistributed. Since because of the internet, it's so easy updating a language library. If you use them, use what? These classes provided in the libraries, you are less likely to introduce bugs than when you write code from scratch. So when you write code that is for a class from scratch, you can make mistakes. There is a chance of making mistakes when you write from scratch. So the obvious choice is use, wherever possible, use the classes provided in module library. Only if they are not suitable, you make your own class. Designing classes and objects. You have to have getters and setters. Getters, they get an attribute of the object. get, like read, and setters update attribute values. What is there? You will update with new values, like writing. This is like reading and this is like writing. Constructor instantiates the object and assigns initial values to the attribute. When you make an instance, the constructor is the one that makes a copy of the class. It creates an object with the associated setter and all those things. Object that assigns initial values to the attributes. Right? A property. A property combines the attribute with its associated setter and or getter. And then the key terms, getter, a method to access its associated attribute. Constructor, a special type of method, that's also a method, that's also a code, that is called to create a new object and initialize its attributes. All the attributes which are there originally, create in the object also, same way, like a copy. Setter, method to set the value of its associated attribute. It's a small program or a procedure or a subroutine which will change the value or set the value of its associated attribute. Property, a class member that includes the attribute and also getter and setter method calls to access or set the attribute value. Here is a worked example. How to create a class. Consider the car data from section 27.01. When a car is manufactured, it is given a unique vehicle ID that will remain the same throughout the car's existence. Right? ID will not change. The engine size of the car is fixed at the time of manufacture. That is also the same. The registration ID will be given to the car only when the car is sold. In our program, when a car is manufactured, we want to create a new car object. Right, new car object. We need to instantiate it using the constructor. Constructor is the one which instantiates. Remember that? Like creating the object from the class. Any attributes that are already known at the time of instantiation can be set with the constructor. In our example, vehicle ID and engine size can be set by the constructor. So at the time, those two are known at the time of manufacture, those two are set. So we know those values. So with the constructor, we can set them initially. The other attributes are assigned values at the time of purchase and registration. Subsequent, later only, we will get those details. So we need setters for them. So later on, when you want to update something, that's a setter. The identifier table for car class is shown in table 27.01. This is the table. Identifier table for a class. Look at this. Now you already know it's about the identifier table. All of you know. Then identifies a car. Data type is class. So that's a class we are going to create called car. And the description is class identifier. Vehicle ID. It's a string. Data type is a string. Unique ID assigned at time of manufacture. Registration, string. Date of registration, date. Engine size, integer. Purchase price, currency. So the descriptions give us on this side. Then constructor. Method to create a car object and set properties assigned at manufacturing. So this is the initial one. The very first subroutine is the constructor that has to come. Method, the first method. These are the other methods. Set purchase price. Method to assign purchase price at time of purchase. Set registration. Method to assign registration ID. Set date of registration. Get vehicle ID. Get registration. Get date of registration. Get engine size. Get purchase price. So the setters and the getters. You can represent this information as a class diagram in figure 27.01. This one. So car, the name comes right at the top. Then this section is the attributes, and this section you have the methods. This is a standard way of showing a diagram, class diagram. And these are the attributes. They must be declared as private. We learned about it earlier. Attributes to be private and methods to be public. These are public. The programmers can access only these, not those. But those can be accessed by programmers through these. Set date of registration, here, date of registration. So there is a setup for this. And if you want to get it, get date of registration, that with that you can get the information. That's a class diagram. Writing object-oriented code. Declaring a class. You have the attributes which are private and methods which are public. So repeating so that we'll remember them. Declaring a class in Python. Now we are coming to Python. Constructor. Getters and setters can be declared in Python. So this is the way you have to type. Class car. Class is a keyword class and this is the name. This is 2 underscore characters are required before and after init to define the constructor. So this is a constructor. As we learned, the very first method is a constructor, always is a rule. And these 2 underscores and characters are required before and after init to define the constructor. And here also, self is the first parameter in the parameter list for every method. So every method, this first parameter should be self. Then there can be others. Then self, so you are referring to this self dot, that is this object dot and 2 underscores here again. Vehicle ID equals n. This n which came from the parameter passing, it will be assigned to this. Self dot registration equals empty string. Self dot date of registration, none. Self engine size equals E. So that value will come from here. We discussed earlier, the vehicle ID is known. The engine size is known at the time of manufacture, but not registration, date of registration, purchase price. Those are later. So the constructor, with the constructor, you can set all the known ones. That is what is meant by that. Then you have the setters. Def, again, define, this is in Python. Set purchase price is the name of the method. And one parameter, the self, comma, P. So the P will come, from the, is a parameter, when you say set purchase price and give a value, 2000 or something like that, it will go and do this. Self dot purchase price equals P. So where self dot purchase price is this. At the moment, initially it was made 0, a float. And here we are setting it. Purchase price equals P, which may be like we have given 2000 20,000, 1 million or whatever, right? That is set to this. Likewise, all these things are done. Set registration, it updates with the R parameter. Then not which is passed from here, but when you the individual method will pass this parameter here, R. Likewise, set date of registration, this D will come and D will be assigned to this date of registration there. Same way, the getters, get vehicle ID, get registration, date of registration, all those things. So that is the way a class is defined. Now let's have a look at the program, the sample. I have already done it. Let's see whether it corresponds to our text. Right? Here it is, class car. Yeah, and the def in it, this is given, 2 underscores, no? A private. All these things are given. And constructor here is it's constructor, then that is after, can say the setters, set purchase price, self P. So exactly the same I have done. So no need to go through each and every one. And if you run this, what happens? Nothing happens because you have not done anything. No, you have just created. For example, now if you take the class I is the name of the class. So we just type car. It will give you the class and then main and how this is shown. Right? We say print. Now let's see how you instantiate an object. But now here you can say if you say car dot engine size. Here you can't just say center. You can't, no? If object car has no attribute engine size. See, that is why it's called private. But you have the get engine price. So let's try that one. And if you put a dot here, now type car and then put a dot, you will get what is available. So it's a in size method, right? Get engine size, missing one required positional argument self. So where is the get engine size? Get engine size self. So and we put self there. We put self, what happens? Self is not defined. So we say now we can try this one. Car set. Set engine size is not there. No, set registration. Empty string. Yes, string. Yes. Set registration. Then we have to give the value. Right? We are setting a registration. Registration equals ABC. Now if we check registration, then it will tell ABC. If we take car get registration, get yes, get registration is there. It doesn't, you can't access as I told you. So it will give the like an address. Now let's see. So this program is there. Now let's see what comes next, how you instantiate and operate on those methods. These are Python also supports properties. So this is another method. You can just go through it, but no need to go very seriously into it. Note that not all properties provide a setter. Only where attribute values are not, where values are to be changed, only where it is to be changed. So instantiating a class. We have already created a class called car that we saw. Now let's create an instance object of this car class and call it this car. This is the way. This is the way we create an object with values. Remember, you have to give the values. There were two value parameters, if you could remember, n and e. And then this object is created. It will give we had your registration. No? Get registration. Blank. No? We have yeah, it gets that. This engine size. Let's try the engine size. Huh? But this is earlier we set the ABC to car, not this car. Right? But we have set this with the constructor. So this car dot engine size. Get engine size. Because it's a method, you have to put the brackets. Don't forget the brackets here. You put like a function. Function also you have to put no procedures. So now you get 2,500. Now if you want to change this car, set engine size. Set engine size is not done because why? Can you think of why? The engine size is not there. You can't change it. No? You can't change the engine size after the manufacture. So those things are set. You no need to get is there. Yeah, get engine size is there, but set is not there because you can't change. But let's see whether you can. This car engine size equals 3,500. That worked here in this case. And now if you check dot get engine size and brackets, not give the new one because why? Where is protected? This will not. There is no setter. No? Here they are. This is what we say. You can't change directly, only through the method. And yeah. So method will have to pass on the what you call the parameter. Let's see the engine size, but then there is no setter. That is a problem. There is no setter for engine size. Using the method, let's call the set purchase price method to set the purchase price at 12,000. How? This way. The Python program now, shell rather, and there we write this car purchase price 12,000 with a parameter, right? Now this car dot get purchase price. Again, yeah, you have to look at the parameters. It's not so easy. You have to check on the format. Get what are we getting now? Purchase price. Oh no, sorry, I have done the wrong one. You want to get no? So this get purchase price. Get purchase price. Yeah. Two brackets. See how nicely it goes on. No loose way of doing things. Only through the methods. Let's do this again. Purchase price 21,000. Now let's get the price. Get purchase price. Yeah. Change to 21,000. Record, like a record, and in a file, the record, how we change it. Get and print the vehicle ID. Get and print the vehicle ID. What do you do? Print this car dot get vehicle ID. Print this car dot vehicle ID using properties. Yeah. So let's try this one. Yeah, that's a thing. That's the property I told you not to worry about this. You have to use this. We went on this line. We didn't follow the other method properties. So unless you do like that, there is a problem. Object has no attribute car, vehicle ID, you mean car, you have to, yeah. So you have to give all those, see how don't follow these methods, you cannot get into the data so easily. So encapsulated and protected. Can't just simply do. So it is protected from programmers' accidental change or erasure. Can't even erase or delete or can't erroneously change it. Here's a task. 7.01. Copy the car class definition into your program editor and write a simple program to test that each method works. A business wants to store data about companies they supply. The data to be stored includes company name, email address, date of last contact. Design a class company is the name of the class, and draw a class diagram. Write program code to declare the class. Company name and email address are to be set by the constructor and will never be changed. Instantiate one object of this class and test your class code works. So that's a very good task for you to do. So let's do the first part and see in Python. Copy the car class definition into your program and write a simple program to test that each method works. Not going to do everything for all the setters and getters, but we'll just check this is the way to instantiate, create the object. This is the class definition there, that's finished. Now this is the main program, and this car equals car, and you pass these two parameters. And also, this is what are the parameters, if you can remember? The two parameters, ID and the ID and the engine size. They don't change, remember? Those two. Then purchase price, at the time of purchase, we said this car dot set purchase price 12,000. That's a parameter. So we can check whether these two are working and also whether these two are working. Get vehicle ID and get purchase price. If you want, you can even check this registration also. So this is vehicle ID. Sorry, this is vehicle ID and the purchase price. And this is engine size. If you want, you can even check that. So let's try this and see what happens. Is what we did was ABC 1234 this parameter, and then the 12,000 here. We want the 2,500. That's the engine size. Can do like print this car dot get engine size. Yeah, size, and don't forget the two brackets and closing bracket for print. Right. Now let's see. There it gives the engine size also. So that is the way to test out whether these are working. And this one I'm not going to do because this is an exercise that you should be able to do by now. A business wants to store data about companies they supply. So similarly, you can copy. You can look at the reference and refer to it and then do it. Design a class company and draw a class diagram. Class diagram, if you don't do it, you will not forget. Don't neglect this, somehow do it. Then, and also submit for correction. 27 for inheritance. Normally, in day-to-day, real life, real world situation is you inherit. Who inherits? Generally, the children from parents, no? Wealth, knowledge, many things, right? Inherit, passing on from one generation to the other. In this case, class, a base class or superclass. From that, the subclasses inherit. There's a class here, at the top, the base class or the superclass. Then the subclasses below them will inherit from the top one. Inheritance, called inheritance. Subclasses get the attributes and methods. But do they inherit the attributes and methods which are set here of the base class, as well as having their own attributes and methods? So here, what we discussed earlier, you can remember the diagram. We had at the top, it was a class. Then you had the attributes with the data types and all that, and the values. And then the methods, the constructor and the method. Whatever that we put here, when you have a subclass defined from that, will inherit all those from this. So here, inheritance diagram A, standard, and B, alternative. This is an alternative diagram. This is a standard one, but this is also acceptable, is also okay. Inheritance. All attributes and methods of the base class are copied to the subclass. That is the meaning of inheritance. Here's another worked example. 27.02, implementing a library system. Implementing a library system. Consider the following problem. The college library has items for loan. The items are currently books and CDs. Items can be borrowed for 3 weeks. If a book is on loan, it can be requested by another borrower. Reserved, right? No reserving until the book comes and someone else can reserve it and keep request. So this table 27.02, this one, library system information, shows the information to be stored. For the book on this side, for the CD on that side. Title of book, title of CD. So no problem there. Author of book, artist of CD, similar. Unique library reference number, unique library reference number. Whether it is on loan, whether it is on loan. The date the book is due for return. The date the CD is due for return. Here is a different factor. Whether the book is requested by another borrower. That is there. The type of music on the CD, or the commonly called genre of the CD. So these two only are different. They are not common to both. So then if you have this library system, the superclass or the base class, and the subclasses here, book and CD. Inheritance diagram for library item, book and CD classes is inheritance. So all except, you can understand, you can imagine now, no? You can predict before they teach us. You can predict that without this, all the others can be in this superclass. They'll be inherited here. Plus these individual ones. This will go to the book and that will go to CD. That is how you must predict and you must learn. If you're wrong, doesn't matter, but you must try to learn. So analyzing the attributes and methods required for all library items and those only required for books and only for CDs, we arrive at the class diagram in figure 27.04. Start with library item, that's a class. You get the title as string, author, artist as string, item ID integer, on loan, boolean, whether it's true or false, whether it's on loan or not. Due date, the date. Then all library items have their attributes. All these are there. Then comes the methods. So as usual, the first one is a constructor. Then get title, get author, artist. All these are these ones. Get item ID, get on loan, get due date. 1, 2, 3, 4, 5. So all 5, the getters are there. All library items have these methods. All library items will have these methods, irrespective of whether CD or book. Then there are additional methods here. Borrowing. returning print details. Class diagram for library item, book and CD. So the subclasses, right? Book, CD. What is the name of the class? Library item. Now these we are creating two subclasses called book and CD. What do you get in there? Is requested Boolean. Then here, genre is string. So that is what we saw in that table. The last item was not common to both. Attribute specific to book class. So this is, for the book class, this is specific. And this one, attribute specific to CD class. They are not common. And in that case, you have certain methods also in these two methods. Methods specific to book class. Constructor. So even in this, you have to have the constructor. So get is requested, set is requested, and get genre, set genre. Method specific to CD class is method specific to book class. Abstract class, a base class that is never used to create objects directly. So that's a different kind of class. It's called abstract class. Won't create objects directly. Declaring a base class and derived classes or subclasses in Python. How do we do that? Import date time. So you need for the library, you need this due date and all that to be calculated. There are no built-in functions in the normal, this program language, but you can get it from the library. What library? Not this book library, the program, the language library, module library. Right? Well, at the beginning of this chapter, we learned about modules, the library, why we are using the well-tested modules rather than writing our own the coding. Otherwise, for this, you will have to write maybe 100, maybe 150, maybe 1,000 lines of coding to do this. We don't know. And testing will take another long time. Instead of that, what we do is import from the library a module called datetime. Then, as usual, now we are familiar with this class library item. Then the initializer method, you do this get title. Other get methods go here. So you can put all the other methods. These not complete. Then the additional subroutines called borrowing, returning, and print detail. So self.onloan equals true. Yes. Self.due date equals self.due date plus. So you are updating with 3 weeks. Because of this date, because of the date time there, we can say due date equals due date plus date time dot time delta weeks 3. So that will calculate the 3 weeks, the deadline, the returning date. Print details, same way, we give the printing details and all that. Now a subclass definition. Again, class, below the first one, class, book. Subclass, book, library item. And here, subclass, CD, library item. So passing that. F init, self, TAI. 3 parameters. This statement calls the constructor for the base class. From the base class, you take this library item. Remember, library item is the base class, no? That name. So if we put that and dot and this init, this, you are calling from that. These 3 are from the initial one. Then self dot is request equal for, setting the values here. Def get is requested self and return the if it is whether is requested or not, it will return the value. It's a Boolean value. So you can do this easily. You must do it. You can copy this or type. Type is better, though it takes time. Typing is better because you remember. Otherwise, if you just copy and paste, you might forget. And then do it and see for yourself. Programming is not a thing that you can watch and learn. You have to do practically and then remember. Can't memorize either. So instantiating a subclass. Creating an object of a subclass is done in the same way as with any class. In Python, this book equals book and the parameters title, author, item ID. This CD equals CD, title, artist, and item ID. So by passing, you can send the common ones also, right? That is also there because though the CD and the book, they have a very few attributes, they have inherited. They have the built-in ones. They have inherited from the base class. Using a method, using an object created from a subclass is exactly the same as an object created from any class. Using an object created from a subclass is exactly the same as an object created from any class. So just the same. Any other way, if you do, it's the same. Any other class or the subclass. Using a method, here is another task for you, 27.03. Write code to define a borrower class as shown in the class diagram in figure 27.05. Is a figure 27.05 borrower class diagram. The class diagram is given. You have to do the coding. So the attributes are there, the methods are there. You only have to do the coding. By now, I'm sure you are familiar and you are capable of doing that. The constructor should initialize item on loan to 0. Right? Initialize, that is the constructor. While constructing, you have to give this as 0. Then update items on loan. Right? Update items on loan, this method should increment items on loan by an integer passed as parameter. So you have to pass a parameter and it will update items on loan. How many books are already borrowed? Write a simple program to test the methods. A lot of programming exercises, very good for you. You must do somehow. Then polymorphism, these are theory things that you must learn. Although the method in the subclass will have the same identifier as in the base class, the method will actually behave differently. This is known as polymorphism. Read again. Although the method in the subclass will have the same identifier as in the base class, the method will actually behave differently. This is known as polymorphism. That means different classes, right? No? The method behaves differently for different classes in the hierarchy. Same method, but it will be different in different classes. The code shown here includes a call to the base class method with the same name. So define the print details method for book, def print details self, print book details. That's just a heading line. Library item dot print details self. So this is a method, print detail. This line calls the base class method with the same name. Okay? And print self dot is requested. This is in the base class, library item. Task 27.04, use your program code from 27.02. Redefine the print detail methods for the book class and the CD class. Test your code. So different print detail for book class because they are different, and the CD class. And you have to test your code. See whether those methods work. 27.5. User program code from task 2703. Add another attribute, borrow ID, to the library item class so that the item being loaned can have the borrow recorded. So you have to change the program a little. The objects, the attributes have to be changed. Borrower recorded. Now at the moment we don't have who borrowed the book. We don't have that record. Change the library item. Dot borrowing. Change the library item dot borrowing and library item dot returning, those two methods, so that loan item dot borrower ID and borrower dot item on loan items on loan are updated when a library item is borrowed or returned. So you have to change those methods accordingly. 2706, use your code from 2702 or task 2704. Add another attribute requested by, some more addition, requested by to the book class so that the borrower making the request can be recorded. So because then you must know who requested, no? Otherwise you have to go looking for unless the requester remembers and comes back. Until then, the librarian cannot lend that book to anyone else. That is a problem. Change the method book.set is requested so that book.requested by is updated when a book is requested. Whatever book is requested, earlier it is false, it has to be made true when somebody requests to reserve a book. Use your code from 27.6 to write the complete program to implement a simplified library system. Write code to provide the user with a menu to choose an option. An example of a menu that would be suitable is shown in figure 27.6. Add a new one to add a new borrower, 2 to add a new book, likewise it goes on, and 9 to exit program. Enter your menu choice. So depending on the input, this will happen. So you have to write code to provide the user menu with a menu to choose an option, an example of implement a simplified library system. So yeah, all these things we know, we have the subroutines already prepared. Put them together. When you click this, add a new book will take place. The garbage collection. Objects are created and they occupy memory. Correct? No? When you run a program, the whole program comes to the memory, as well as now the objects are also created in memory. In the procedural, you don't have that. The instructions are just carried on. But here, we create an object and that has to remain in the memory. When they are no longer needed, sometimes the book is finished now, you have to go to CD and the book is not required. They should release that memory to be reused. So when there are other programs coming into work, if you don't release it, then there's a problem. If objects do not let go of memory, we will run out of memory. This is known as memory leakage. Like memory has leaked and memory has finished. That is a term used. How do our programming languages handle this? So don't worry about this, huh? Don't worry, because Python memory management involves a private heap containing all Python objects and data structure. Management of the Python heap is performed by the interpreter itself. The programmer does not need to do any housekeeping. Housekeeping is a term used for that kind of thing, cleaning up the memory, erasing whatever that is not necessary. Those things are called housekeeping. Like tidying the bedroom and all that in our house, housekeeping, washing and cleaning. So containment, also called aggregation. The base class is the most general class. Subclasses derived from this base class are more specialized. And remember this book and CD? Base class is general. It has attributes and methods common to both book and CD. But the book and CD class, they are more specialized. Containment means that one class contains other classes. For example, a car is made up of different parts and each part will be an object based on a class. The wheels are objects of a different class to the engine object. So they are different. Engine is one, wheels are one, like that. The engine is also made up of different parts. So the engine also has different parts in turn. Right? Together, all these parts make up one big object. Like the car made up of all spare parts. Here also the objects, different objects only made one big object. Containment again. A relationship in which one class has a component that is of another class type. The containment relationship is shown in figure 27.07. Aggregation class diagram. This is the diagram. Car, part of the wheel is a part of the car. Is a symbol. Right? Going to example 27.03. Using containment. The college runs courses up to 50 lessons. The course may end with an assessment. Object-oriented programming is to be used to set up courses. The classes required are shown in this figure. Course, the base class is course. And there are subclasses, lesson and assessment. Course has the attributes course title as string, maximum students, max students is integer, number of lessons integer. Course lesson of lesson, this is an array. This is an array with 50 elements and of lesson, not of integer, string or anything, of lesson. So that is this type. So this is in this, right? This is contained in that, right? Of lesson. Course assessment. That's assessment. Yeah? Another one like that. Another type. So both these are there. Then the constructor is there as usual. Add lesson method, add assessment method, output course details method. And in the subclasses is a containment. That is why this is contained in that, this is contained in that. That's what you call containment. Lesson title, just not there, it's string. Duration, because these lessons must have these, not the assessment. Duration minutes, integer. Requires lab, boolean, true or false. And constructor and output, lesson details. Here, assessment title, max marks, constructor and output assessment detail. The one method. So that's containment. Assuming that all attributes for the lesson and assessment classes are set by values passed as parameters to the constructor, the code for declaring the lesson and assessment classes is straightforward. This code below shows how the courses class, the course class is declared. Course class, base class. Class, course, then definite this same type. If you do 2-3 programs like this, you will easily remember these two. But don't forget the 2 underscores here and 2 underscores there. And the first parameter to be self. But I must tell you, but this is not a Python rule, Python or any language rule. This can be changed if you want. This is not compulsory that it should be self. You can have another name here, another word here. But that word has to be used everywhere. This selfie just to indicate that this one, say this number, this student, this month, like that. For that only this self. Otherwise, the word self doesn't have a meaning. So sets up a new course here with this. And with these attributes, course title, max students, number of lessons, and all these. Then you have the methods, add lesson, add assessment. Then we have the outputs. Then you have a Python test program. So you can make use of this also to test. Earlier there was a task which required you to test the program. So def main, this is, we have done like def main, and then below that you have to run main. You have to say main, otherwise it will not run. The main module. We are defining classes, we're defining functions, procedures. So, but we have to have the def main if you do that. Otherwise, just the line will do. But this is the better way. Define main. My course is equals, my course equals course. That's it. The class we have course computing. The two parameters now computing and the number. Sets up a new course. So when you want to set up a new course, create an object like this. My course dot, then the methods come with this dot notation. My course dot add assessment. This is the assessment name. You go into it, and 100 is a max marks. Remember the two parameters, maximum marks. Adds an assignment. Another one, it's an assignment. It's a new course. Earlier we had the base class. My course dot add lesson, problem solving, 60 and false. False is lab is not required. This one is number of lesson. And this is the course name. Likewise, you have, for this you need the lab. Programming, you need the lab. Theory also, no need of the lab. Check it all works. My course dot output course details. So that should, we have defined already. If you test that in your main program, it should output those details of the course. Then the final task, write the code required for the lesson and assessment classes. Add the code for the course, class, and test your program with the appropriate simple program from worked example 27.03 previously. So that is the end of chapter 27. And since this is on the first page, you can go through it again and again. Then somehow do the tasks. So till the next lesson, see you. Bye.